This is section 10.1, part 3. In this video, we're going to talk about the different errors we can make when testing a hypothesis. Unfortunately, their names are type 1 error and a type 2 error. And those aren't very descriptive, but we'll discuss when we make those errors, which one is more severe, and what we do to try and limit the occurrence of making either of these types of errors. Alright, if you're not a Star Trek fan, then I'm sorry that this is completely all about Star Trek as far as our example and talking about the errors that we could possibly make. As far as characters, Dr. McCoy, whose nickname is Bones, and you'll see that here in just a second, is the doctor on the ship. Captain Kirk, of course, is the captain. And Spock is the science officer, and he is going to help Dr. McCoy with the decision that has to be made. In this case, we're looking at someone dying. So, he's dead, Jim, said Dr. McCoy to Captain Kirk. Mr. Spock, as a science officer, is put in charge of statistically determining the correctness of Bones' statement and deciding the fate of the crew member. And there's two possible fates. He's either going to vaporize him, obviously if he's dead, hopefully he's going to vaporize him if he's dead, or try to revive him if he's not dead. So this is our setup that we have to start this example. So let's see if we can come up with a null and alternative hypotheses for this situation. So of course, our null hypothesis is our statement of no change. Our alternative hypothesis is what we're looking for evidence in order to support it. So our null hypothesis, in this case, the crew member came off the ship, went down to the planet or wherever it is that he's been battling. We would assume that a statement of no change would mean that he is alive. So the crew member is alive. That's our statement of no change. What we're looking in order to support, or the evidence we're looking for in order to support Dr. McCoy's claim is that he is no longer alive. So he is not alive. Of course, that's the same as saying he is dead. So there's our null and alternative hypotheses. Now, here's the thing. One of those is true. We can't control which one of those is true, and that's what we're going to talk about on our next slide. But we can try and make the best decision possible to identify which of these is true. Alright, so when we talk about states of nature, what we're talking about is the true nature of things. So in this example that we're dealing with, either this crew member is alive or he's not. And like I said, we don't have any control over that. If he's already dead, he's dead. There's nothing we can do. If he's still alive, he is alive, and we can try and hopefully revive him. But there's no way we don't have a control over which of these possibilities is true. Instead, we need to make a right decision. Oh no. I deleted the wrong thing, but there we go. So I want to delete that. There we go. We have no control over which of these is true. What we do have control over is the decision that we make. Alright, so we have to be able to make a decision about which of these we think is true. If the patient is alive, then the null hypothesis is true and the alternative hypothesis is false. If the patient is dead, then the null hypothesis is false and the alternative hypothesis is true. We have to pick which of these two things we believe. Do we believe the null hypothesis or do we believe the alternative hypothesis? Now, in order to do that, we have to make a decision. And we have control over our decisions. We use our evidence, but we do have control over our decision. One decision we can make is to reject the null hypothesis. If we reject the null hypothesis, what that means is that we feel that we have evidence to believe... Oop, I didn't spell that right. Believe the null is wrong. So for whatever reason, if we're rejecting the null hypothesis, it's because we have enough evidence to believe that that null hypothesis is wrong. We have to have the evidence in order to do that. The other decision we could make is to fail to reject the null. And of course, we don't have the evidence. That we need in order to reject it. So it's not, we have to be careful because we never accept the null hypothesis. So we're not accepting it, we just don't have the evidence to reject it. If we go back to our court situation, what are the two possibilities that the jury can come, the two primary ones, of course, there's things with insanity and some different things like that, but the two main verdicts that a jury can come back with is either guilty, they're rejecting the null hypothesis, or not guilty. They do not accept the null hypothesis. Remember, our null hypothesis in that situation was that they were innocent. Let me put this on a new slide just really quick, and then we'll go back to our Star Trek. All right, so just so we can see. So our null hypothesis for a court would be that the defendant is innocent. Because that's what we assume. We assume that everyone is innocent until proven guilty. So that's our statement of no change. Our alternative hypothesis, I don't know why I dotted my one. There we go. Our alternative hypothesis is that the defendant is not innocent. Which, of course, we always say defendant is guilty. So, when I reject the null hypothesis, then I'm saying I do not believe that he or she is innocent based on the evidence provided. So I have that evidence, and that's enough for me to say, nope, sorry, you are guilty. Now, if I, see if I can move that up just a little bit. Yes, I can. My other option is to fail to reject. And what that's going to look like is for me to say, not guilty. If I were to accept the null hypothesis, that would be like trying to say that they are innocent. But we don't do that. We don't do that in statistics, and we don't do that in a courtroom. The jury does not come back and say that someone is innocent. They say they're not guilty, that there's not enough evidence in order for me to say that they are guilty. So that's where that difference is. And that's true for all of our decisions. So our decisions are to reject or fail to reject. We never accept the null hypothesis. One reason for this is because we're always dealing with samples. Now, of course, this isn't for the courtroom, but just in general with hypothesis testing. We're dealing with samples. Somebody else could get another sample from our same population and end up with different results, because what happens with samples? What do we know about samples? Samples vary. Hopefully you can, quote, everybody can say that with me. Samples vary all the time. And so somebody else could come up with a sample that's more extreme than ours or less extreme than ours. And we don't want to choose one of these. We can say that our evidence was strong enough to reject the null hypothesis, but if we have evidence that we can't reject, we don't want to say, oh, well, I believe the null hypothesis forever and nobody can prove any differently. Well, somebody else can get a different sample and they could say, well, now I have enough evidence to reject the null and you look foolish because you said you were going to accept it forever and always. So that's why we don't want to accept the null hypothesis. All right, so this leaves us with 4 possibilities. So we can reject the null hypothesis or fail to reject it. But in both cases, the null hypothesis could be true or the null hypothesis could be false. So what do these look like? Well, let's start with our states of nature. If the null hypothesis is true, what does that mean? Well, that means that the patient is alive. And regardless of our decision, that's our state of nature. That is what is true. If the null hypothesis is false, then what that means is that true to the nature of the person, that patient is dead. Now, our decision, however, could be different. If we reject the null hypothesis, what does that mean? Well, that means that we have evidence of death. Regardless of whether the patient is alive or dead, we believe that the patient is dead. We have evidence of death. If we fail to reject the null hypothesis, then that means we have insufficient evidence of death. So we don't believe that they're dead. We're getting a pulse rate. We're getting some brain waves. We're getting whatever scans Spock is doing. He believes that this person is still alive. And so this is what our 4 possibilities are. But what does this really mean? All right, so if the patient is alive, but we think, or Spock believes, that he is dead, what's going to happen? Well, first of all, let's make note of what Spock's choices are. Spock is either going to vaporize or try to revive. Now, if he believes that the person is dead, he's going to vaporize him. So in our first box here, we said that the patient was alive, but there's sufficient evidence of death. That means that Spock is going to vaporize. Well, that's not a good color. There we go. A live person. Okay, so that's probably not a good thing. So remember, the null hypothesis is false. That means that the patient is dead, and we have evidence of death. Well, if Spock thinks he's dead, he's going to vaporize a dead person. And that's okay. I mean, I hate that he's dead, but, decision-wise, that's okay. Now, what if we fail to reject the null hypothesis? Well, in Spock's situation, if he fails to reject the null hypothesis, that means that he believes there's insufficient evidence of death, or he believes that he can still revive him. So he's going to try to revive a live person. That's good. That's also, again, decision-wise correct, and bonus, the person's not dead. And then what if the null hypothesis is false? So again, the patient is dead, but for some reason Spock still believes that there is insufficient evidence of death. So he's going to try to revive him. But it's going to be trying to revive a dead person. And, that's kind of gross. But, that's... So there's a mistake here as well. But what we're going to talk about as far as our definitions, is which of these two mistakes is worse and how can we prevent them. So again, we've got two correct decisions. Vaporize a dead person or try to revive a live person. That's what we hope. We hope that we can make the correct decision. But we have two errors. And that's vaporizing a live person and trying to revive a dead person. Hopefully you agree that vaporizing a live person is the worst of the two. And that is the one we're going to try and prevent. Alright, so a type 1 error is the equivalent of vaporizing a dead person. Vaporizing a live person. Which is bad. Someone was alive and now we vaporized them, so they're not anymore. The equivalent to this in our court system would be to convict someone who's not guilty. So convicting an innocent person. And in both cases, these are worse than the other error. Of course, we don't want to make either error, but there is a saying, it is better to let 10 guilty men go free than to incarcerate one innocent man. This is actually a quote from back in the late 1700s by an English jurist, William Blackstone. And he was talking about the laws and how the law should be in England at that time. So since a type 1 error is the one we really want to prevent from occurring, then what we do is we make sure that there's a low chance or a low probability of this happening. So there's a few things that we need to identify. The first is alpha. Alpha is the probability of committing a type 1 error. What we typically call alpha is the significance level. And we saw this is the complement of our confidence level. So if I have a significance level of 0.05 or 5% significance level, then that would be the same as looking at a 95% confidence level. A type 2 error is the other type of error that we can make, but it's less severe. So this would be trying to revive there we go, a dead person, or not convicting a guilty person. So again, in both of these cases, this is still a mistake, and we don't want to make a mistake if we can help it. However, this is just less severe. In this case, for the Star Trek example, this is just a waste of time, maybe a waste of resources, trying to revive a dead person. You're wasting time and energy and maybe even money, but you've not taken someone's life away. And honestly, that's similar to not convicting a guilty person. Yes, they're guilty. Yes, they should be in prison or on probation or fined or whatever the punishment was going to be. They should have been convicted, but there wasn't the evidence needed to do so. But you've not taken away an innocent person's life or part of their life while they've spent time in jail. And so it's just not as severe. It's still a mistake. So please, as far as the ethical and social conversations about, should we let people go free? Well, no, that's not what we're saying. We're just saying that we would rather let someone go free who's guilty than to put someone in prison who is innocent. So there's just, we're the lesser of two evils. So the probability of committing a type 2 error is called beta. We're not going to use it other than me telling you right now that this is beta. So beta is the probability of committing a type 2 error. We're not really going to do anything with beta. We're going to focus on alpha. We're going to focus on that significance level being small. And if you go to an advanced statistics class, then you can talk about beta and the power of the hypothesis test, and you can do all sorts of great things with preventing type 2 errors. But we're not going to focus on that in this class.